Video lesson number 28. So what we're going to be talking about today in video lesson number 28 is calculating mechanical advantage. I'm just going to always use MA, mechanical advantage, for inclined planes. Now when we talk about this, we do have to involve some math. I know, which is probably some of y'all's favorite thing on the planet here. But the reality is you have to know what you're doing to get these questions correct. So when you're using an inclined plane and you're walking up the hill here, you have to know, why do you use this? How does it help you? So let's go ahead and get started. Now this has to do with the notes that are on page 118. So I want to go over those real quick so you guys can be reminded of what was on page 118. So the formula for mechanical advantage is output force over input force. So this is output force divided by your input force. Another way to look at this is your length divided by your height. Okay, so I gave a couple of examples here, and we'll go over these again. But it says if a wheelchair access ramp has a length of 10 meters and a height of 2 meters, what is the mechanical advantage of the ramp? Well, all you got to do is plug your formula, plug your numbers into your formula, and you can see that mechanical advantage equals your 10 meters, which is your output force or your length, over 2 meters, which is your input force or your height. So 10 meters divided by 2 meters yields 5. So your mechanical advantage of this example would be 5. In example 2, it says calculate the mechanical advantage in the situation below. So again, we have another ramp. We have a gentleman that's pushing a barrel up of an inclined plane. The length of the inclined plane is 15 meters. The height of the inclined plane is 5 meters. Using our formula, mechanical advantage equals output divided by input. We're going to have 15 meters divided by 5 meters, which is going to yield a mechanical advantage of 3. Okay, so you can't forget this formula. This is the most important piece right here. Mechanical advantage equals output divided by input. Okay, or another way to remember it is length divided by height. So let's do a couple of practice examples here and see what we can come up with. I'm going to zoom out just for a second. So let's say we have a ramp, okay, or an inclined plane. We have a gentleman here pushing a box. He's pushing the box up the ramp. And when we are looking at the example, let's say the ramp is 10 meters long and the height of the ramp is 5 meters. Okay, what is our mechanical advantage? All right, well, mechanical advantage formula, if you guys remember, is our output divided by our input. In this case, output is our length, so 10 divided by our height of 5 equals 2. So our mechanical advantage for this example is 2. All right, let's try one more just to make sure everybody understands this concept. If you have the formula memorized, or if you use the formula provided, it's pretty straightforward. All right, let's say we have a guy on this side, and he's going to be rolling this barrel uphill. All right, so he's going uphill. He's trying to save himself some headache from not pulling it directly straight up. He's going to use his wheelchair access ramp, and this ramp happens to be 35 meters long, and he's going to increase the height of the barrel by 7 meters. So mechanical advantage equals output divided by input. In this case, it's going to be 35 divided by 7. So our mechanical advantage is going to be 5. So pretty straightforward on this. I don't want to spend a whole lot of time on it, but just remember, make sure you use the formula, plug your numbers in correctly, output divided by input.